So what we're going to do now is we're going to take a look at a case study that illustrates Java completable futures. And this case study is something called the ImageStreamGang case study. We've talked about this before in other contexts. Now we're going to talk about it in the context of Java completable futures. So this particular app, which you can get at the link at the bottom of the slide, applies several Java parallel and concurrent and asynchronous frameworks to do the following types of things. It takes a list of URLs to images, and it will ignore any images that are already cached. It will then download non-cached images. It'll apply a list of filters to each of the images that it downloads. It'll store the filtered images into the file system, and then eventually it'll arrange to display the images to the user. So those are basically the steps that are involved in this particular app. And we'll see that there's a bunch of different ways to do this. We're going to compare and contrast completable futures with parallel streams. Parallel streams is something we've talked about before. And the thing to note is that there are different pipelines here. They both use streams, but one of them is parallel streams, and the other is sequential streams with completable futures. So basically, here's the parallel version, which we've looked at before. In this case, we take the list of URLs. We will filter out any ones that have already been cached already, because there's no sense in re-downloading them again. We'll then go ahead and download the non-cached images using download image in the map intermediate operation. We then apply a bunch of filters to map, and that'll end up returning basically a stream of streams, which we then go ahead and concatenate together with reduce and stream concat. I kind of left that out here. And then finally, we collect everything up into a list. So that's the parallel streams version. All the behaviors in the parallel stream variant are synchronous. And as we've discussed in recent quizzes, what that means is that they block until the operation is finished. The alternative approach, which is what we're going to focus on now, and which actually looks to some extent a little bit like your programming assignment number 3, is a version that's based on sequential streams and completable futures. So as you might expect, all the behaviors in the completable futures variant will be asynchronous, because that's the nature of the beast. So what we're going to do here is we're going to ignore any cached images asynchronously. We're then going to take the non-cached images and download them asynchronously. Then we're going to go ahead and apply a list of image filters to the downloads after they complete asynchronously, and we'll filter them and store them in the file system asynchronously. So that's all asynchronous. And then finally, we're going to collect all the results together, and that will cause everything to run asynchronously. So, of course, as always is the case with streams, nothing really happens until we hit the terminal operation, which in this case is collect, and then everything starts to run. And as you can see here, we're going to use our little toFuture collector, the futures, future stream collector, or whatever it's called, futures collector stream, I think. And that'll go ahead and collect everything up, and it'll all run asynchronously. And when we're all done, we're finally going to go ahead and get the results of the asynchronous computations. So this is a wonderful tour de force illustrating all the cool features of Java streams, sequential streams, and how they can be combined with Java completable futures. Remember, by the way, why we use sequential streams with completable futures. It's because it's overkill to use parallel streams. There's no need to use parallel streams and completable futures. We just need to use sequential streams, because the completable futures are already doing the asynchrony and the concurrency. And ultimately, the images are displayed to the user through a cool little widget. So what's nice about this is by combining completable futures and sequential streams, we can efficiently close the gap between the domain intent and the implementation by letting the stream structure the way in which the flow of control works in the program. So it's very easy to read and see what's happening at a high level. And then we use the completable futures to do a very optimized job of downloading all the images and transforming the images and storing the images asynchronously. So it's kind of the best of both worlds, if you will. Your implementation for assignment 3 is a slight bit different. It doesn't use streams quite as aggressively, but it's much the same idea. We're going to see later when we talk about reactive programming that there's yet other ways of doing this using reactive programming techniques and reactive programming frameworks like Project Reactor or RxJava, and that will give yet a different variant on this whole approach. As we'll see later, this is kind of a preview of coming attractions. what's going to happen with the reactive model is that we use reactive streams instead of combining sequential streams and completable futures. And reactive streams gives you this wonderful ability to do asynchrony within a conventional streams-like model, but it's all done in a way that can be done asynchronously. So it's super, super, super cool. All right, so that's the end of the quick overview, just giving you a big picture view of where we're headed with what we're about to talk about.